Now, life on Earth requires these three things. You can almost say this looks like the recipe for life. Now, it looks more like the recipe for life. But if you were making a cake at home, you don't just pour flour on the counter, crack an egg on top of it, light it on fire, and expect there to be a cake. That would not make a cake. That would just make your parents mad. What we need to do is we need to assemble these ingredients for the right amount of time in a stable environment, like a baking pan. Now, when we talk about life, a stable environment might look like could not survive without schnapps. Every living thing we have ever found has schnapps floating around inside of it. So everybody say schnapps.
Schnapps.
There you go. The sixth most important for life. Life is water. There's lots of water in the universe. Water in a bag. Okay. Now for ingredient number 2, we need shooting stars. Meteorites. Meteors, basically. Here's a nice picture of a comet. See, when a comet comes through the solar system, it heats up. Things fall off of it. They form a tail. Earth passes through that tail, and that debris causes shooting stars. Raise your hand if you've ever seen a shooting star before. Keep your hand up if you want to guess how big it was. How big is a shooting star? Like how big? No, it's not as big as the world. They're called stars, but they're not. In the very, very back. Yes, in the very, very back. Yes.
It's big as a planet.
No, not that big. You. 2 football stadiums. That would cause a lot of damage if it hit, but it's possible. This room, we're getting closer.
Size of
Yes. We're about the size of a football now. We're getting closer. 99% of every shooting star you will ever see was a grain of sand. That's it. That's all it took. They do get bigger. There are some chunks of rock the size of a football stadium floating out there. If a Volkswagen Beetle were to fall into our atmosphere right now, it would entirely burn up before it hit the ground. But all it takes, and most shooting stars you ever see, were just a grain of sand. What you actually see when you see a shooting star, this little grain of sand is coming in very quickly. It's pushing on the air in front of it. When you squeeze air, it gets hot. When something gets hot, it gives off light. You're actually looking at the atmosphere glow because of that grain of sand. That's all it took. So we'll add some shooting stars. Now, in science, we call these silicates and particulates. Next summer, when you go to the beach, you can make a silicate and particulate castle. But if you call it that, I guarantee someone's going to kick it over. Okay. Ingredient number 3, we turn to this picture, which is a close-up of what we call the nucleus, the real important part. It was a lot grayer than imagined. And that gray comes from this, carbon. Remember, schnapps. Here we have carbon in the form of charcoal. It has some crushed up for us. If you make a comet at home, you could use different forms of carbon, like the graphite from your pencil, or your mom's diamonds. Don't tell her I told you that, though. Okay, so we have some carbon. Now, we need Windex. It's a little known fact. The Johnson Corporation, a family company, spends billions of dollars every year to fly out to these comets and bring back the precious Windex ore. They're then refined into the precious Windex that they sell at a tremendous loss to their company. No, this is not true. We don't find Windex in comets, but there's something in Windex we do find in comets, and that is...
Phosphorus.
Nope. Ammonia. A different chemical. But yes. Now, ammonia is the active ingredient in Windex. It's also the active ingredient in cat urine. We're going to use Windex. It's a lot easier to bottle. All right. Now, the reason that I brought that up is because ammonia is what's called an organic compound. There are other types of ice than water ice. Things like those other schnapps ingredients can be arranged in different ways. So the ammonia in the Windex is going to stand in for things like methane and ethane, things that tend to blow up, which I'm not allowed to play with anymore. All right. So, water, shooting stars, carbon, and the other schnapps, you mix it all together, and there's your comet. No, that's not a comet. That's just gross. The problem here is that it's not solid. We need our comet to be a solid chunk. See, in outer space, you can be a liquid or you can be a gas, but you can't be a liquid in outer space. Just like on Mars, the atmospheric pressure idea. If you were an astronaut and you went into outer space and you didn't have your spacesuit on correctly, your blood would suddenly turn into a gas, and it would come out of you. Long before you have a chance to suffocate in the vacuum of space, that is how you would die. Isn't that pleasant? Now, I need to freeze this comet into one solid chunk. I could throw it in the freezer and you come back and talk to me in a couple of days, but I also have the dry ice. And that makes perfect sense. There's different types of ice. We find carbon dioxide in comets. So, I'm going to put on these gloves because carbon dioxide is dangerously cold, and I'm going to add some dry ice to our comet and hopefully get the whole thing to freeze together. But I do need everyone's help. Science just doesn't work without the maniacal laughter. So when I add this dry ice, I need everyone to laugh like a scientist. We'll practice just once. Mwahahaha! Very good. This is going to work. Don't let me down. All right, get ready for it. Can't do it without you. Now, we stir. It's important that you stir your comet. You don't shake the comet. That just bruises the Windex. I don't care if you are James Bond. Ooh, we're starting to make a mess, and that's a very good sign. Yep, I can feel it chunkifying in there. Not a scientific term. And now, gravity takes over. Gravity takes all of this junk, all of this debris, and just crunches it down into a single object. This is a process that takes millions of years. No, don't worry, we don't have that one. Alright, I think it worked out. I rip open the bag of science, and if everything went according to plan, honestly, how often does that happen? We have a comet. Thank you. And this is exactly what a comet would look like. To see a comet from Earth, it would have to be the size of a mountain. But they do come in all sizes, and every time they get close to the sun, they get a little bit smaller. Even famous comets like Halley's Comet will not last forever. It'll eventually disappear. But all of that stuff that's inside of you, all of those ingredients for life, are out there in the universe. Again, Earth is a very special place, but the possibility for life is out there, for sure. Could there be aliens? I think it's only a matter of time before we find them. Now, ladies and gentlemen, again, my name is Clark. I'm a museum guide. I hope you enjoyed the show. I hope you enjoy your day. Find a museum guide like me and ask us a question. It really helps us do our job. Yeah.